Now, let us look at what Leibniz theorem is. So, let us first look at the statement of this and see where this theorem can be used. So, if you have two functions f and g, whose nth derivative exists, Yes, these are two functions which can be continuously derived n times. Then d by dx power n of f into g, dn fg by dx n is equal to, that is, the nth differentiation of the product function. The nth differentiation of the product function is equal to NC naught Fn of x times g of x. Is NC naught times the nth differentiation of just f times g of x plus NC1 times Fn minus 1 of x into g1 of x is the first differentiation of x. N minus 1th differentiation of x into g dash of x plus NC2 Fn minus 2 of x, that is n minus 2th differentiation of f of x into g double dash of x. g2 of x means double differentiation of g with respect to x plus NC3 times Fn minus 3 of x times the third differentiation of x plus so on, and this pattern goes similar to the binomial expansion. Lastly, NCn f of x times the nth differentiation of g of x. So nth differentiation of f of x into g of x plus NC1 times n minus 1th differentiation of f of x into first differentiation of g of x, n minus 2th differentiation of f of x into second differentiation of g of x, so this is called Leibniz theorem. This theorem will be very useful when you need to find the higher order differentials of product functions. For example, if you want d4 by dx power 4 of e power x into cos x. So e power x into cos x, I want the fourth differentiation of this. So normally if you have to do this in the general process, what we do is we assume y is equal to e power x cos x. This is a product function. So first we'll differentiate it once, dy by dx is equal to, by product rule, e power x into minus sin x plus cos x times e power x. So next we need to go to second order differential, d square y by dx square is equal to, so we can take e power x as common. So e power x times cos x minus sin x's differentiation is minus cos x minus sin x plus cos x minus sin x times e power x. So now you got the second differentiation of this function. Next you have to go to third differentiation. Next you have to go to the fourth differentiation. You have a lot of steps involved in this. Takes a lot of time. So this type of functions can be differentiated very easily using the Leibniz theorem. In Leibniz theorem, what we can do is we can think of these two differentiations differently, separately. So d4 by dx power 4 of e power x cos x is nothing but nc naught, that is 4c naught into the fourth differentiation of e power x. So we know that e power x, as you differentiate it, go on getting e power x. So e power x times the second function as it is plus 4c1 times the third differentiation of e power x is e power x into the first differentiation of cos x is minus sin x plus 4c2 times the second differentiation of e power x is e power x into minus sin x is next differentiation is minus cos x. So you have to go on differentiating this again and again. plus 4c 3 times the first differentiation of e power x is e power x into the third differentiation of cos x, that is the differentiation of minus cos x is sin x, plus 4c4 e power x into sin x's differentiation is again cos x. So now as you can see, 4c1 e power x into minus sin x, 4c3 e power x into sin x, these two are getting cancelled. So what is left out? 4c0 is 1, 4c2 is 6, 4c4 is 1. So e power x cos x minus 6 e power x cos x. So you get the answer as minus 4 e power x cos x. So this will be the fourth differentiation of e power x cos x. So this process looks simple, right? So whenever you have product of two functions which need to be differentiated, a lot of times you can use the concept of Leibniz theorem.